26th of July, 1945, Hauptmann Friedrich von Schroeder sat in a bare concrete room at a British interrogation facility outside Brussels. His Knight's Cross still hanging round his neck, a sardonic gesture by his captors, who wanted him to remember what he'd lost. The 42-year-old Panzer commander had spent 4 years terrorizing Allied armor across North Africa and Western Europe, destroying 63 enemy tanks before a bazooka team finally stopped his Tiger outside Ocon the previous October. Now, 8 months after Germany's surrender, he found himself face to face not with an interrogator, but with something far more unsettling: understanding. Major Robert Henderson of the United States Army's Technical Intelligence Division pushed a stack of photographs across the metal table. They showed assembly lines, production charts, logistical reports, documents von Schroeder had never seen during his years of combat. The American officer who'd commanded Shermans through France and into Germany wasn't there to extract military secrets. Those secrets were worthless now. He was there because someone in Washington wanted the German tankers to comprehend the machinery that had crushed them. Von Schroeder picked up the first photograph with hands that still bore burn scars from his last battle. It showed the Chrysler Tank Arsenal in Detroit, a facility so vast it seemed to stretch beyond the photograph's edges. According to Henderson's accompanying documentation, this single factory had produced 11,000 tanks during the war. 11,000. Von Schroeder's entire panzer division had never fielded more than 200 tanks simultaneously. The Germans' expression remained stoic, but Henderson noticed the slight tremor in his fingers. Von Schroeder had grown up believing in German engineering superiority, in the invincibility of the Tiger and Panther tanks that could pierce Sherman armor from distances the American tanks couldn't hope to match. He'd seen it with his own eyes: 5 Shermans burning for every Panzer lost. His crews had joked darkly about Ronson lighters and Tommy cookers, mocking how quickly the gasoline-powered Shermans ignited when penetrated. Henderson let the silence build before speaking in heavily accented but serviceable German. "You destroyed how many Shermans personally?" "Hauptmann 63 confirmed kills, your file says." "Impressive." He paused, sliding another document forward. "The Americans built 49,234 Sherman tanks during the war. The British built another 7,500 of their variants." The number hung in the air like artillery smoke. Von Schroeder had known the Allies possessed numerical superiority. Every German soldier knew that, but the scale of it, spelled out in captured production records with American efficiency, carried a different weight. He'd been fighting an enemy that could replace every tank he destroyed nearly 900 times over, according to United States Strategic Bombing Survey reports compiled after Germany's surrender. As referenced in these documents, German tank production never exceeded 19,400 vehicles of all types throughout the entire war. The celebrated Tiger tank, the behemoth that von Schroeder had commanded with such pride, numbered only 1,347 units ever produced. The Panther, arguably Germany's best tank, reached production of just over 6,000. Henderson watched the realization dawn across the German officer's weathered face. This wasn't about tank versus tank combat anymore. This was about mathematics, logistics, and industrial capacity, the unglamorous foundations of modern warfare that Prussian military academies had never adequately addressed. The Tiger might have been the superior weapon in direct combat, but war wasn't fought in duels. It was fought in the grinding arithmetic of attrition, supply chains, and replacement rates. Von Schroeder finally spoke, his voice carrying the hoarseness of a man confronting uncomfortable truths. "We knew you had more. We always knew you had more. But this ... he gestured at the photographs spread before him. This is not warfare. This is industrialized slaughter. No, Henderson corrected quietly. This is victory. And it started long before the first shot was fired. 27th of July, 1955. Henderson returned to find von Schroeder already waiting, studying the previous day's documents with the intensity he'd once reserved for tactical maps. The American had brought something new: technical specifications and design philosophy papers for both the M4 Sherman and the German heavy tanks. What followed wasn't an interrogation, but an education in why Germany had lost the war before the first Tiger ever left the factory floor. The Sherman, Henderson explained, had been designed with a revolutionary concept: strategic reliability over tactical superiority. While German engineers obsessed over creating the perfect killing machine, American designers focused on creating a good enough tank that could be mass-produced, easily repaired, and reliably deployed across oceans. The Sherman's relatively simple design meant a crew could swap out an engine in just 3 hours under field conditions. Henderson had personally witnessed his maintenance teams perform this feat in a muddy French field during the Normandy campaign. Von Schroeder countered with technical specifications he knew by heart. The Tiger's 88mm gun could penetrate 180mm of armor at 1,000 meters. The Sherman's 75mm gun, the standard variant, could barely scratch Tiger's frontal armor even at close range. In North Africa, his crew had destroyed 7 Shermans in a single engagement near Kasserine Pass, picking them off like targets at a shooting range, while their rounds bounced harmlessly off his Tiger's glacis plate. "You're describing tactics," Henderson said, pushing forward another document. "I'm describing strategy. Your Tiger was a masterpiece. It was also a maintenance nightmare." He referenced a German military report from 1944 that detailed Tiger operational readiness. Rates hovering around 50%, half of Germany's most feared tanks were inoperable at any given moment due to mechanical failures, lack of spare parts, or damage from the increasingly desperate repair conditions in the field. The Sherman's operational readiness rate, by contrast, exceeded 80% throughout most of the war. This data came from United States Army logistics reports, compiled in 1945, Henderson explained. The American tank used a commercially available diesel or gasoline engine variants existed for both that shared parts with civilian trucks. Every mechanic in the army already knew how to work on it. The transmission, though admittedly fragile in early models, could be repaired with tools available in any motor pool. Von Schroeder shifted uncomfortably. He remembered the endless waits for specialized parts. The Tiger tanks abandoned because a single broken component couldn't be replaced. The gradual cannibalization of damaged vehicles to keep others running. By 1944, his unit had spent more time repairing tanks than fighting in them. The Tiger's Maybach Engineer, magnificent piece of engineering, required precision tools and factory-trained mechanics for any serious repair work. Henderson continued his lesson, describing the Sherman's production timeline. From design approval to the first production models rolling off assembly lines took just 14 months. The Tiger, despite being conceived earlier, required 2 years from design to production, and even then, the complexity meant frequent production slowdowns. The Panther rushed into production after the shock of encountering Soviet T-34s at Kursk, suffered catastrophic reliability problems for its first year of service. Your tanks were better weapons, Henderson acknowledged, but they were worse tools. And war is ultimately about tools. Who has them? How many? And whether they work when needed. He shared another statistic. The average Sherman traveled 8,000 miles before requiring major mechanical overhaul. The Tiger averaged less than half that distance, and the Panther initially managed barely 1,000 miles before its transmission failed. Von Schroeder picked up a photograph showing a Sherman assembly line where a complete tank rolled off every hour during peak production. He'd once commanded a Tiger production facility as part of his staff rotation in 1943. His factory, considered highly efficient, produced 3 Tigers per day at maximum output, and that rarely lasted more than a week before shortages of specialized components forced slowdowns. The American explained the Sherman's modularity. The same basic chassis-supported tank destroyers, self-propelled artillery, armored recovery vehicles, and engineer variants. Production lines could be quickly reconfigured, and parts were interchangeable across variants. German tanks, by contrast, were bespoke machines. A Tiger transmission couldn't fit a Panther. A Panzer IV turret ring was unique to that model. Every variant required its own specialized supply chain, multiplying logistical nightmares. Henderson concluded the day's session with a question that he didn't expect von Schroeder to answer immediately. What's the value of a perfect tank that never reaches the battlefield versus an adequate tank that's always there when needed? 28th of July, 1944. Von Schroeder arrived with questions instead of defiance, and Henderson knew they'd reached the critical moment when professional soldiers set aside pride to understand the machine that had ground them down. Today's lesson focused on the unglamorous truth that decided the war: supply chains, shipping capacity, and the brutal mathematics of transcontinental logistics. Henderson began with a simple question. How much did your Tiger weigh, Hauptmann? Von Schroeder answered immediately. 54 metric tons in combat configuration, 60 tons with additional armor, some units welded on. The American nodded and pointed to specifications showing the Sherman's weight, 30 to 33 tons, depending on variant. This seemingly simple difference in mass cascaded into strategic consequences that shaped the entire war. The German railway system, Henderson explained, had been designed for European warfare with infrastructure that could handle heavy loads. But even German train cars struggled with Tiger tanks, requiring specialized heavy-duty flat cars that were chronically scarce. Moving a Tiger battalion from one front to another consumed enormous transportation resources. The Sherman, by contrast, could be loaded to per standard Allied flat car, doubling transport efficiency. But the real revelation came when Henderson discussed maritime shipping, the invisible battlefield that ultimately decided Germany's fate. The Liberty ships that America produced in staggering numbers could carry 5 Shermans or 2 Tigers based on weight distribution and securing requirements. Since the Allies had to ship everything across the Atlantic or around Africa to reach combat theaters, this ratio determined what actually reached the battlefield. According to United States Maritime Commission records from the war period, American shipyards produced 2,710 Liberty ships, creating a transport capacity that Germany couldn't hope to match or effectively interdict. Von Schroeder had never considered this dimension of warfare. His perspective had been ground level, the view from a tank commander's cupola, where German technical superiority seemed self-evident. Henderson showed him photographs of the port at Southampton in early June 1944, where hundreds of tanks awaited loading for Normandy. The organizational complexity was staggering. Tanks pre-positioned, waterproofed, and categorized by unit assignment. The Americans treated tank deployment like package delivery, while German armor movements were bespoke military operations requiring weeks of planning. The American pushed forward fuel consumption data, and von Schroeder felt his stomach tighten. The Tiger consumed approximately 500 liters of fuel per 100 kilometers under combat conditions, sometimes more in difficult terrain. The Sherman consumed less than half that amount. In a mobile campaign like the breakout from Normandy or the race across France, this efficiency translated directly into operational range. A Sherman could operate 300 kilometers from its fuel depot. A Tiger managed barely 150 before running dry. Henderson described Operation Cobra, the American breakout from Normandy, in late July 1944. Third Army's armored divisions had raced across France, covering distances in days that would have been impossible for German heavy armor simply due to fuel logistics. The Americans had designed their armor doctrine around their logistical capabilities: fast, fuel-efficient tanks that could exploit breakthroughs before enemy defenses solidified. German doctrine, built around defensive battles and counterattacks, assumed short supply lines and readily available depots. Your Tiger was designed for the Eastern Front, Henderson observed. Short moves between prepared positions, fighting defensive battles on your own territory with supply depots nearby. It was nearly perfect for that role. He paused meaningfully. But Germany was fighting a multi-front war across a continent, and you couldn't afford to design different tanks for different theaters. Von Schroeder interjected with the German perspective on combined arms warfare. The Tiger was never meant to operate alone. It was a breakthrough weapon supported by lighter tanks, infantry, and air cover. When used correctly, as in his unit's operations in Normandy, Tigers could hold entire sectors against overwhelming numbers. He'd personally stopped an American armored column for 3 days outside Cannes with just 2 operational Tigers and supporting infantry.
Yes, Henderson agreed. And while you held that crossroads, 50 more Shermans were landing on the beaches, being fueled, armed, and sent forward. 3 days later, when your Tigers finally withdrew or were destroyed, you faced more American armor than when you started. That's the strategic reality. You won tactical battles while losing the logistical war. The Americans showed von Schroeder maintenance logs from his own unit. During the 11 months from D-Day to V-Day, Henderson's Sherman battalion had written off 21 tanks as combat losses. But they'd received 37 replacement tanks during the same period, including complete replacements shipped from the United States. Repaired vehicles returned from depot-level maintenance and battlefield recoveries. The unit's effective strength had actually increased during a year of continuous combat. Von Schroeder admitted that his Panzer battalion had started the Normandy campaign with 41 tanks, a mix of Tigers and Panthers. By the time they retreated across the Seine, they had 14 operational vehicles. No replacements ever arrived. By October, when the Americans finally knocked out his Tiger, his battalion had ceased to exist as a combat formation. 29th of July, 1945. Henderson brought a different kind of document today: training manuals, crew qualification standards, and personnel records. The conversation shifted from steel and logistics to the human beings who operated these machines. And von Schroeder began to understand that Germany's defeat was as much about people as production. The Sherman, Henderson explained, had been designed around a fundamental acknowledgement. Most tankers would be hastily trained civilians, not professional soldiers. The controls were simple, intuitive, and forgiving. The driver's position resembled a truck, which millions of American men already knew how to operate. The gunner's position featured straightforward sighting mechanisms that didn't require months of training to master. According to United States Army Training Command reports, a crew could be trained to basic operational competence in 12 weeks. Von Schroeder's experience had been entirely different. Tiger crew training lasted 6 months minimum, often longer. The complexity of the vehicle demanded extensive technical knowledge, not just how to operate it, but how to diagnose problems, perform field repairs, and understand the intricate mechanical systems. His own training at Paderborn in 1941 had been rigorous, almost academic. He'd emerged from it understanding his tank better than most men understood their own automobiles. Henderson acknowledged this German expertise, then delivered the strategic counterpoint. "You created the finest tank crews in the world," he said. "Then you lost them, and you couldn't replace them." He referenced casualty statistics, showing that by mid-1944, the average German tanker had mere weeks of training before being thrust into combat. The experienced crews, the veterans who understood their complex machines, had been killed, captured, or wounded in 3 years of attrition warfare on 2 fronts. The American described his own crew's composition. His gunner had been an accountant from Ohio. The driver had worked in his family's dairy farm. The loader was a 19-year-old from Brooklyn who'd never seen a tank before basic training. Yet within 3 months of formation, Henderson's crew had functioned effectively in combat. They weren't individually superior to German tankers, but the Sherman's design compensated for their inexperience. Von Schroeder countered with the German perspective on crew quality. A well-trained Tiger crew was a precision instrument, capable of extraordinary feats. He described an engagement near Villers-Bocage in June 1944, where SS Obersturmführer Michael Whitman's single Tiger had destroyed an entire British armored column, more than 20 tanks, and numerous support vehicles in 15 minutes. Such performances required not just good equipment, but exceptional training and tactical genius. Whitman was killed 2 months later, Henderson replied quietly, and no amount of training could replace him. That's the point. You built a system that required excellence to function. We built a system that functioned despite mediocrity. It wasn't an insult, but an observation about strategic design philosophy. The Sherman was a forgiving tank. An inexperienced crew might use it poorly, but they'd likely survive their mistakes and learn. The Tiger offered no such grace. A single error in complex vehicle operation could be fatal. The American explained crew survivability data, and von Schroeder listened with growing discomfort. Sherman crews had roughly a 75% survival rate when their tank was penetrated and disabled, particularly after the introduction of wet ammunition storage in 1944 that reduced catastrophic fires. The tank's relatively spacious interior and multiple exit hatches gave crews precious seconds to escape. Tiger crews, by contrast, faced a survival rate closer to 50%. The vehicle's cramped interior, fewer exits, and tendency to catastrophically burn when penetrated made escape difficult. Henderson shared a personal anecdote. Sherman had been knocked out twice during the campaign across France, once by a Panther near Metz, once by a concealed anti-tank gun in the Hurtgen forest. Both times his entire crew escaped with minor injuries. They'd been reassigned to new tanks within 48 hours and returned to combat. The psychological impact of knowing you could survive a tank's destruction, he explained, was immeasurable for crew morale. Von Schroeder had lost 3 complete crews before his final capture. He'd been the only survivor of his first Tiger's destruction in Tunisia, pulled from the burning wreck by Italian infantry, while 2 of his crewmen died inside. The memory still haunted him, the screaming, the smell, the helplessness. After that, every engagement carried the weight of knowing that his crew's survival depended on avoiding any penetrating hit. The American concluded by discussing replacement crew training. By late 1944, the United States was training tankers in cohesive crew units rather than individuals, creating team cohesion before combat. They practiced together, learned each other's roles, and developed the trust essential for armored combat. Germany, desperate for replacements, was throwing partially trained individuals into depleted units where they were expected to integrate immediately into combat operations. Superior equipment requires superior operators, Henderson summarized. Your system created those operators brilliantly for the first 2 years of the war, but attrition destroyed that expertise faster than you could rebuild it. Our system was designed for attrition from the beginning. 30th of July, 1945. Henderson arrived with technical drawings and field modification reports, ready to address what he knew von Schroeder had been waiting to discuss: the evolution of tank design during the war and why Germany's technological sophistication ultimately worked against them. Von Schroeder began aggressively, pointing out that Germany had led tank innovation throughout the war. The Tiger's 88mm gun, adapted from the legendary anti-aircraft weapon, had been revolutionary when introduced in 1942. The Panther's sloped armor and long-barreled 75mm gun created the template for post-war tank design worldwide. Even the Americans' own post-war patent tank clearly borrowed design elements from captured Panthers. Henderson didn't dispute these facts. We were innovating toward perfection, he acknowledged. We were innovating toward sufficiency. He spread out photographs showing Sherman variants: the British Firefly with its 17-pounder gun, the M4A3E8 E8 with improved suspension, and the high-velocity 76mm gun, the M4A3E2 jumbo assault tank with thicker armor.
Ow.
Each represented an incremental improvement that maintained the Sherman's fundamental reliability while addressing specific combat lessons. The key difference, Henderson explained, was implementation speed. The Sherman Firefly, British modification that finally gave Allied tankers a gun that could reliably kill Tigers, went from concept to battlefield deployment in 6 months during early 1944. The modification was crude, even inelegant, but it worked. Crews loved it, despite its disadvantages, because it gave them fighting chance against heavy German armor. Von Schroeder contrasted this with German innovation cycles. The King Tiger, designed to address the original Tiger's limitations, entered production in early 1944, but suffered from rushed development. Its transmission, borrowed from the Panther, couldn't handle the vehicle's 16-ton weight.
Oh.
According to German military records Henderson had obtained, King Tigers suffered mechanical failure rates exceeding 70%. The most technologically advanced tank of the war was also one of the least reliable. Henderson described visiting a captured King Tiger near Cologne in March 1945. The massive tank sat abandoned, not from combat damage but mechanical failure. Its crew had torched it to prevent capture, but examination showed the transmission had failed completely. The tank had traveled less than 200 kilometers from its factory before breaking down, a magnificent achievement of engineering rendered useless by overcomplexity. The American explained the philosophy behind Allied incremental improvement. Rather than designing revolutionary new tanks mid-war, they'd focused on making the Sherman progressively better. The wet ammunition storage modification introduced in early 1944 reduced catastrophic fires by 75%. This single change, implemented across the entire Sherman fleet within months, saved thousands of crew lives. German tanks received no comparable safety improvement because their production system couldn't accommodate rapid, widespread modifications. Von Schroeder argued that Germany had no choice but to innovate radically. The shock of encountering Soviet T-34 tanks at the start of Operation Barbarossa in June 1941 had forced German designers to leapfrog current designs entirely. The Panther was a direct response to the T-34's superior sloped armor and mobility. Without revolutionary design changes, German tanks would have been obsolete by 1943. Exactly, Henderson agreed, turning the argument on its head. You were constantly reacting to enemy innovations, while we dictated the pace of the armor war. The Sherman's basic design remained viable throughout the conflict, because the Americans had anticipated future needs. The tank's relatively spacious turret ring allowed gun upgrades without fundamental redesign. The hull structure could accommodate armor improvements. The powertrain had growth potential for heavier variants. Henderson showed von Schroeder field modification reports from his own unit. American tankers had welded spare track links onto their Sherman's frontal armor, creating improvised protection. They'd added sandbags, concrete, extra armor plates, whatever worked. These modifications weren't officially sanctioned, but commanders tolerated them because they improved crew survival. The Sherman's simple construction made such field expedience possible. German tanks, by contrast, were too precisely engineered for field modification. Adding weight to a Tiger affected its already stressed transmission. Altering the Panther's carefully calculated armor scheme could compromise structural integrity. Von Schroeder remembered rejecting his crew's attempts to add extra armor to their vehicles because division engineers warned it would cause mechanical failures. The American referenced a study by the United States Army Ordnance Department analyzing knocked-out German tanks. Why, as the war progressed, increasing percentage of abandoned German armor showed no combat damage. They'd been destroyed by their own crews when mechanical failures left them immobile. By contrast, abandoned Shermans overwhelmingly showed battle damage. The implication was clear. American tanks fought until killed. German tanks often died of mechanical ailments. Henderson concluded with a broader observation about innovation strategy. We're trying to design the perfect tank while fighting a war. We accepted good enough and focused on winning the war. Perfection is the enemy of sufficiency when you're on a timeline. Germany's pursuit of technological superiority had consumed resources, delayed production, and created logistical nightmares managing multiple complex tank types. America's acceptance of the Sherman's limitations had allowed focus on production, deployment, and support. 31st of July, 1945. Henderson arrived with maps and strategic planning documents, ready to address the ultimate question: how strategic-level decisions about tank design shaped the war's outcome before the first shots were fired in anger. Von Schroeder studied a map showing global Allied supply line shipping routes from the United States to Britain, from Britain to Normandy, from American ports to North Africa, from Australia to the Pacific. The sheer scale was overwhelming. Henderson explained that every strategic decision about the Sherman had been made with these supply lines in mind. The tank had to be small enough to ship efficiently, simple enough to maintain far from factories, and reliable enough to operate across climates from the Sahara Desert to Belgian winter to Pacific jungles. German tank design, by contrast, had been optimized for European theater warfare within relatively short distances of German industrial centers. This wasn't incompetence, it was rational planning based on Germany's strategic position. The problem was that rational planning assumed Germany would fight the war on its own terms. Instead, Germany found itself fighting defensively across a continent with supply lines that stretched beyond breaking. Henderson referenced the United States Army's pre-war planning documents from 1940 to 1941 before American entry into the war. These strategic assessments, proven remarkably prescient, had identified key requirements for American armor: must be transportable by ship, must operate in multiple climate zones, must be maintainable by average mechanics, must be producible by automotive industry, must be reliable for extended operations far from supply bases. The Sherman had been designed to meet these specific strategic requirements. Von Schroeder argued that German planners couldn't have anticipated fighting a defensive war across multiple fronts simultaneously. The Wehrmacht's doctrine in 1939 and 1940 assumed short, aggressive campaigns, blitzkrieg operations, where complex vehicles could be supported by relatively short supply lines. The Tiger and Panther were perfectly suited for these operations when used as intended. But strategic situations change, Henderson countered, and strategic designs should anticipate that change. He showed von Schroeder comparative data on tank deployment times. Sherman could be offloaded from a ship, fueled, armed, and driven to a frontline position within 24 hours of landing. A Tiger required specialized unloading equipment, immediate mechanical inspection, careful positioning of fuel supplies, and coordination of specialized maintenance support a process, taking days even under optimal conditions. The American explained how this deployment differential had shaped the Normandy campaign. After D-Day, on 6th of June, 1944, Allied forces landed thousands of vehicles, despite ferocious German resistance and difficult beach conditions. German reinforcements, including heavy panzer units from southern France and the interior, took weeks to reach Normandy. Some units spent more time moving to the battlefield than fighting once they arrived, their complex vehicles breaking down on the journey. Von Schroeder interjected with the German perspective on armor concentration. Wehrmacht doctrine called for massing armor at decisive points, creating overwhelming local superiority, even if outnumbered strategically.
Yes.
This approach had worked brilliantly in France in 1940 and in the opening phases of Barbarossa in 1941. The problem was that by 1944, Germany lacked the operational mobility to mass armor effectively, while the Allies could deploy armor broadly and concentrate rapidly using their superior logistics. Henderson showed von Schroeder photographs of American armored divisions on the move across France in summer 1944. The images showed hundreds of vehicles moving in parallel columns, crossing rivers on prefabricated bridges, refueling from tank trucks that traveled with the formations. The entire system was designed for sustained mobile operations, not individual tank superiority but systemic operational capability. The German contrasted this with his own experience during the retreat from Normandy. His panzer battalion had moved primarily at night to avoid Allied air attacks, often traveling single file on narrow roads because French infrastructure couldn't support parallel column movement of heavy vehicles. Fuel trucks were priority targets for Allied fighter bombers, leaving tanks immobile. Maintenance vehicles fell behind, leaving damaged tanks unrepairable. The entire system collapsed under operational stress. Henderson introduced data on strategic mobility, the ability to move forces between theaters. The Sherman's design allowed relatively rapid redeployment. Units that fought in North Africa in 1943 fought in Sicily months later, then Italy, then France. The same basic supply chain, maintenance procedures, and spare parts supported operations across multiple theaters. German heavy armor, once committed to a theater, generally stayed there because redeployment was logistically prohibitive. The American asked von Schroeder to consider a thought experiment. What if Germany had designed a 35-ton tank with adequate armor, a decent gun, simple maintenance, and high reliability? What if German industry had produced 30,000 of these instead of mixing Tigers, Panthers, Panzer IVs, and various other types? Von Schroeder admitted the strategic appeal, but argued it would have required abandoning German technical advantages and accepting inferior vehicles. Inferior by what measure? Henderson challenged. Tank versus tank combat? Yes. But war isn't fought in duels. It's fought by systems, production systems, logistics systems, training systems, maintenance systems. The Sherman was superior in every system except direct combat capability. We designed it that way intentionally. He explained that American planners had calculated they could afford a 3-2-1 loss ratio and still win through systemic advantages. The actual ratio in many engagements was worse than 3-2-1, but the strategic calculus held. Von Schroeder finally confronted the core truth he'd been avoiding. Germany had fought the wrong war with the right weapons. The Tiger was a masterpiece designed for a war of maneuver and breakthrough operations. Instead, Germany fought a war of attrition and strategic defense, where systemic advantages mattered more than tactical superiority. 1st of August, 1945. Henderson brought documents that told a story von Schroeder had never fully considered. How American industrial culture shaped the Sherman's design and Germany's industrial limitations doomed even the most brilliant tank designs to strategic irrelevance. The American began with automotive production statistics from 1941, the last peacetime year for the United States. American factories had produced nearly 4 million automobiles that year, more than the rest of the world combined. This massive automotive industry, Henderson explained, wasn't just a source of production capacity, it shaped American thinking about vehicles as mass-produced, interchangeable, maintainable consumer goods rather than bespoke mechanical systems. Von Schroeder listened as Henderson described how the Sherman's design deliberately borrowed from automotive industry practice. The tank used commercial engine designs versions of engines powering trucks, buses, and aircraft. Its transmission, while military-specific, used design principles from automotive gearboxes. The fire control system, electrical system, and hydraulics all reflected automotive industry approaches. Adequate performance through robust simplicity rather than exceptional performance through complex precision. German tank design philosophy, Henderson observed, came from a different tradition, precision mechanical engineering, where each component was carefully crafted for optimal performance. This approach created magnificent machines but required manufacturing infrastructure, fundamentally different from mass production. According to captured German industrial reports, Tiger production required 40,000 man-hours per tank. Sherman production required 10,000 man-hours. The difference was design philosophy. German tanks were assembled by skilled craftsmen. Shermans were mass-produced by semi-skilled workers using automotive industry techniques. Von Schroeder defended German precision engineering, noting that American mass production created quality control problems. He'd examined captured Shermans and found welding inconsistencies, rough machining, and assembly variations that would have been unacceptable in German production. Some Sherman holes showed visible differences in armor, thickness, and quality between production lots. Henderson nodded, acknowledging these quality variations. But here's the critical question. Did those variations affect battlefield performance significantly? He referenced United States Army maintenance reports showing that Shermans from different manufacturers and production periods had nearly identical reliability and combat effectiveness. The design's inherent simplicity and robust tolerances meant that minor manufacturing variations didn't matter. The tank worked despite imperfections. The American explained the concept of design for manufacturability, creating products that could be built efficiently with available tools and workforce. The Sherman's hull was made from relatively flat armor plates welded together rather than the complex curved shapes of German tanks. This design was easier to manufacture, required less skilled labor, and facilitated faster production. The rolled homogeneous armor used on Shermans was simpler to produce than the face-hardened armor on German tanks, even though German armor was theoretically superior. Henderson showed von Schroeder photographs of American tank factories, converted automobile plants with assembly lines where Shermans moved down conveyors just like cars. Specialized workstations performed specific tasks: hull welding, turret assembly, engine installation, final systems integration. Workers became expert at narrow tasks rather than needing comprehensive mechanical knowledge. This organizational approach allowed rapid training and high productivity. Von Schroeder contrasted this with his visit to the Henschel plant, where Tigers were built. He remembered skilled workers hand-fitting components, adjusting tolerances, and customizing assemblies to ensure perfect operation. Each Tiger was unique, essentially a custom-built machine. The craftsmanship was impressive. But Henderson's documents showed this approach limited production to a trickle compared to American output. The American introduced the concept of supply chain integration. The Sherman used standard fasteners, bearings, seals, and components that existed in American industrial catalogs. Replacement parts could be sourced from multiple suppliers, preventing production bottlenecks. German tanks used custom components manufactured by specific suppliers, sometimes single-source suppliers whose destruction by bombing immediately halted tank production. Henderson described the impact of Allied strategic bombing on German tank production. The attacks didn't just destroy tank factories, they disrupted the complex web of specialized suppliers that German armor depended on. Factory making custom transmission gears gets bombed, and suddenly Tiger production stops for months while that capability is rebuilt. Sherman production, using more generic components, proved far more resilient to supply chain disruption. Von Schroeder raised the issue of raw materials, noting that Germany lacked access to many critical materials after 1941. The molybdenum for high-quality armor steel, the chromium for various alloys. The nickel for many components, Germany struggled with shortages while America had nearly unlimited access. Henderson acknowledged this, but argued that Sherman design specifically anticipated potential material shortages by using more common materials and simpler metallurgy. The American concluded by showing von Schroeder production timelines. American industry had converted to tank production in months during 1941 and 1942, with automobile factories retooled for Sherman production in as little as 4 months. German tank production was centered in specialized facilities that couldn't easily expand or relocate. When the Allies began serious bombing campaigns in 1943 and 1944, German production became increasingly disrupted while American production accelerated. "You built tanks like they were machine tools," Henderson observed. "We built tanks like they were trucks. Your approach created better individual tanks. Our approach created a better tank system. And in modern industrial warfare, systems defeat individual excellence." 2nd of August, 1945. Henderson brought combat reports and tactical analyses, ready to address what von Schroeder considered the ultimate test: actual battlefield performance and the reality of combined arms warfare. Von Schroeder began with accounts from his own combat experience, engagements where tactical excellence and superior German equipment had achieved remarkable results despite overwhelming odds. Near Cannes in June 1944, his Tiger Company had destroyed 47 Allied tanks over 3 days of fighting, while losing only 2 of their own. At Arnhem in September, German armor had devastated British airborne forces and supporting tank units. These weren't anomalies, but representative of German tactical proficiency. Henderson didn't dispute these accounts. Instead, he asked von Schroeder to consider what happened after those tactical victories. "The British lost 47 tanks at Cannes," Henderson noted, "but within a week had replaced them and resumed offensive operations. Von Schroeder's Tiger Company, despite its success, had retreated because it couldn't hold against continuous Allied pressure, reinforcement, and artillery support. Tactical excellence had merely delayed strategic defeat." The Americans spread out after-action reports from Operation Cobra, the American breakout from Normandy in late July 1944. These documents told a different story than individual tank duels. They showed how the Sherman functioned within a combined arms system that negated German tactical advantages. Henderson explained that American doctrine never envisioned Sherman's fighting Tigers in fair duels. "That would be stupid," he said bluntly, "like bringing a knife to a gunfight." Instead, American tactics called for combined arms coordination. When reconnaissance units spotted German heavy armor, they called in artillery fire massive concentrations that forced German tanks to button up and seek cover. Then fighter bombers would attack, particularly the devastating P-47 Thunderbolts carrying rockets and bombs. German armor had been suppressed by indirect fire would American Shermans maneuver to engage, often from multiple directions simultaneously, using speed and numbers to overwhelm individual superior German tanks. Von Schroeder objected that this wasn't tank warfare, it was simply exploiting Allied air superiority and artillery advantage. Henderson agreed completely. "Exactly. That's the point. We designed a tank doctrine that integrated with our strengths rather than trying to match your strengths." The Sherman's relatively thin armor wasn't a fatal flaw when operating under friendly air superiority. Its modest gun was adequate when supporting infantry advances rather than hunting enemy armor. Its reliability and speed enabled the rapid maneuvers that combined arms doctrine required. The American showed von Schroeder radio logs from his battalion's operations. The documents revealed constant communication between tank units, infantry, artillery fire, direction centers, and tactical air controllers. This coordination, Henderson explained, required reliable radios that could function in all weather conditions and relatively simple tactical procedures that hastily trained troops could execute. The Sherman carried excellent radio equipment. American communications technology was consistently superior throughout the war. Von Schroeder contrasted this with German communications difficulties. Radio production shortages meant many German tanks lacked adequate communications equipment, particularly later in the war. Company commanders often had difficulty coordinating their units, and coordinating between arms tanks, infantry, artillery, air support was frequently haphazard. The Wehrmacht's initial successes had relied on superior training and leadership to overcome communications limitations, but by 1944, those advantages had eroded. Henderson described a specific engagement near Ericourt in September 1944, where American 4th Armored Division had destroyed or disabled nearly 300 German tanks, including many Panthers, while losing fewer than 50 Shermans. The American tankers hadn't won through superior equipment, but through superior tactics. They'd identified favorable terrain, established defensive positions, coordinated with artillery, and picked apart German armored attacks as they funneled through predictable avenues of approach. Von Schroeder studied the Ericourt report with professional interest. The German defeat there had resulted from poor reconnaissance, inadequate preparation, piecemeal commitment of forces, tactical errors, compounded by fuel shortages that prevented proper coordination. But he noted that when individual Panther tanks engaged Shermans at favorable ranges, the Germans still held overwhelming advantages. The problem was creating those favorable conditions. Henderson agreed, but emphasized that modern warfare rarely allowed combatants to dictate ideal conditions. Your tanks were optimized for best-case scenarios, clear fields of fire, adequate support, prepared positions. Our tanks were optimized for worst-case scenarios, communication breakdowns, operating independently if necessary. The Sherman's simple operation meant even a confused, disorganized crew could still fight effectively. German armor required coordination and tactical sophistication to function properly. The American introduced casualty data that complicated simple assessments of tank effectiveness. While German tanks destroyed more Allied tanks per engagement on average, Allied tankers survived more frequently and returned to combat more quickly. Henderson's own experience illustrated this, knocked out twice, back in action within days both times. This crew's survivability meant veteran American tankers accumulated experience even while losing multiple vehicles, whereas veteran German tankers who lost their complex tanks often died with them. Von Schroeder raised the psychological impact of facing superior German armor. He'd heard accounts of American units hesitating or refusing to attack when Tigers were reported in an area. Henderson acknowledged this Tiger fear had been real, particularly in Normandy, but noted that the arrival of the Sherman Firefly and the 76mm gun variants had largely resolved it by autumn 1944. More importantly, American doctrine evolved to avoid situations where Tiger fear mattered. Don't attack Tigers frontally. Bypass, suppress with artillery, or call in airstrikes. The Americans showed Von Schroeder gun camera footage from P-47 Thunderbolt fighter bombers attacking German armor. The images showed rockets and bombs devastating even heavy tanks from above. Henderson explained that the Sherman's real strength was functioning as part of a combined arms team where air power could engage armor. Artillery could suppress positions, infantry could screen movements, and tanks could exploit opportunities. German armor, increasingly lacking air cover and artillery support, fought piecemeal without systemic advantages. Henderson concluded with an observation that struck at the heart of von Schroeder's professional identity. You were trained to be armor commanders, to think about tank versus combat, breakthrough operations, exploitation. We were trained to be combined arms commanders who happened to ride in tanks. The Sherman was designed for that role. Tiger wasn't. Neither design was objectively better. They served different doctrines. 3rd of August, 1945. Henderson arrived with documents from the war's final months, the period when systemic advantages had overwhelmed tactical excellence so completely that the outcome became mathematically inevitable. Von Schroeder knew this period intimately, having lived through Germany's collapse from inside a Tiger tank. By late 1944, his unit had been essentially destroyed at Aachen. But the story Henderson told extended far beyond individual experience to the entire German armored forces' disintegration under pressures that superior tank design couldn't overcome. The American began with fuel statistics that told a brutal story. By September 1944, German synthetic fuel production had fallen to less than 30% of summer levels due to Allied bombing of oil facilities. Fuel allocations for armored units were cut repeatedly, first to 70% of normal levels, then 50%, then whatever could be scrounged from increasingly chaotic supply systems. Henderson showed von Schroeder documents capturing German tank units that had sufficient operational vehicles but insufficient fuel to move them. The Battle of the Bulge in December 1944 illustrated this collapse perfectly. Germany had massed its last reserves for a desperate offensive through the Ardennes, including some of the finest remaining panzer divisions, with relatively large numbers of Panthers and King Tigers. Henderson showed von Schroeder captured German orders that depended on capturing American fuel dumps to sustain the offensive. The German army literally couldn't carry enough fuel for its own tanks to complete their objectives. Von Schroeder remembered hearing about the Bulge offensive from his hospital bed, where he'd been recovering from his wounds. The initial reports had been optimistic surprise achieved. Allied lines penetrated, American units surrounded. But within days the offensive stalled, and not primarily because of American resistance. German tanks ran out of fuel and had to be abandoned. Complex vehicles broke down in winter conditions and couldn't be repaired. The Wehrmacht had gambled everything on achieving impossible objectives with insufficient logistics. Henderson contrasted this with American logistics during the same period. Despite the surprise and initial disruption of the German offensive, American fuel supplies never seriously faltered. Tank units that lost vehicles received replacements within days. The Red Ball Express and other supply operations maintained flow of fuel, ammunition, and parts, even through difficult winter conditions. The Sherman's fuel efficiency meant that limited supplies went further, and its reliability meant fewer vehicles were deadlined for maintenance. The Americans showed von Schroeder photographs from the Ruhr Pocket in April 1945, the final encirclement of a major German force in western Germany. The images showed dozens of abandoned German tanks, many showing no combat damage. Crews had simply walked away when fuel ran out, when spare parts became unavailable. When the logistical systems supporting these complex machines completely collapsed, among the abandoned vehicles were Panthers and King Tigers, technological marvels rendered useless by strategic defeat. Von Schroeder found these images particularly painful. He trained on some of these tank types, commanded them, believed in them. Seeing them abandoned like broken toys made visceral the intellectual points Henderson had been making all week. Technology without logistics was just expensive scrap metal. German engineering excellence had created magnificent weapons that the German state couldn't sustain in operation. Henderson introduced data on German tank losses during the war's final months. Surprisingly, a majority of German armor losses in early 1945 were coded as abandoned or destroyed by crew rather than destroyed in combat. Tanks that might have continued fighting for weeks or months and better. Conditions were being abandoned after days when fuel didn't arrive, when spare parts couldn't be obtained, when repair facilities no longer existed. The complex supply chains that German armor required had been completely shattered. The American asked von Schroeder to consider what the final months would have looked like if German had built simpler, more reliable tanks in larger numbers. Von Schroeder admitted that his proud Tigers might have been replaced by 35-ton tanks with adequate guns and armor but vastly better reliability. Given Germany's fuel shortages and maintenance challenges by late war, those simpler tanks might actually have been more combat effective than the magnificent but maintenance-intensive heavy tanks. Henderson showed comparative data on vehicle availability rates during this period. American armored divisions in March 1945 were reporting operational readiness rates above 80%, despite months of continuous combat. German panzer divisions, when they could be contacted at all through deteriorating communications, reported readiness rates below 30%, and many of those ready vehicles lacked fuel to move. The Sherman's simple maintenance and efficient fuel consumption provided overwhelming advantages when support infrastructure collapsed. Von Schroeder raised one final defense of German armor. Even in defeat, German tanks had maintained kill ratios favoring German forces. American casualties had been heavy, despite victory. Tens of thousands of American tankers killed or wounded. The Tiger and Panther had never stopped being deadly weapons. They'd simply been overwhelmed by numbers and logistics. Yes, Henderson agreed quietly. And that's exactly what we designed for. We accepted higher casualties, knowing our replacement system could sustain them, while yours couldn't. He showed von Schroeder casualty statistics comparing German and American tank crew losses. The raw numbers favored Germany, but the trend lines told a different story. American losses were steady, but sustainable. German losses accelerated as experienced crews were killed and replaced with inadequately trained crews who died faster, creating a death spiral of declining effectiveness. The American concluded with a map showing the final positions when Germany surrendered on 8th of May. Allied forces occupied all of Western Germany, having advanced from the Rhine to the Elbe in less than 6 weeks. That rapid advance had been possible because Allied armor could move reliably, refuel quickly, and sustain operations continuously. German forces, even where they possessed operational tanks, couldn't coordinate effective resistance because their armored units lacked mobility. Henderson made his final point. The Tiger was a better tank than the Sherman in every measurable combat characteristic: armor, firepower, crew protection, and direct engagement. But the Sherman was a better war-winning tool because it was designed for the reality of industrial warfare rather than the ideal of armored combat. 4th of August, 1945. On their final session, Henderson brought no documents, no photographs, no statistics. Instead, posed questions that forced von Schroeder to synthesize everything they'd discussed into a coherent understanding of how the Sherman had won the war, despite its tactical inferiority. Von Schroeder began with a confession. Before this week, he'd believed Germany lost because of strategic errors, Hitler's interference in military operations, the two-front war, the failure to develop atomic weapons, the betrayal by Italy and other allies. These explanations preserved his professional pride. German soldiers and equipment had been excellent. The leadership and strategy had failed them. Henderson's relentless focus on logistics, production, and system design challenged that comfortable narrative. The American asked von Schroeder to consider an alternative history. What if Germany had designed and built a simple, reliable 35-ton tank in 1940 and produced 30,000 of them by 1945 instead of the complex mix of Panzer IIs, IVs, Tigers, Panthers, and various other types? Von Schroeder worked through the implications. Simplified logistics, unified training, easier maintenance, lower fuel consumption, higher operational readiness. Rates the systemic advantages would have been substantial. But von Schroeder also noted the counterfactual problems. German intelligence had known about the T-34 by late 1941. Simple 35-ton German tank would have been outclassed by Soviet armor, potentially leading to even worse defeats on the Eastern Front. The Tiger and Panther had been necessary responses to enemy capabilities. Germany couldn't simply ignore the arms race in tank technology. Henderson offered a different perspective. The real question isn't whether you should have built simpler tanks, it's whether you should have been fighting this war at all. He explained that the Sherman's design philosophy assumed fighting a war where American industrial capacity, naval power, and eventual Allied coordination would create overwhelming advantages. Germany, lacking these strategic foundations, could never have won a prolonged attrition war, regardless of tank design. Von Schroeder pushed back, noting that Germany had nearly defeated the Soviet Union in 1941 and 1942. If Moscow had fallen, if the Caucasus oil fields had been captured, if the Wehrmacht had achieved its objectives before American industrial might fully engage, history might have been very different. The Tiger and Panther, though late to the battlefield, had extended German resistance far longer than simpler tanks could have. The American conceded these points, but returned to the fundamental issue. German strategy required quick, decisive victories before attrition warfare could develop. The Tiger and Panther were designed for a war Germany was already losing by the time they entered service. They were magnificent solutions to tactical problems in a war that would be decided by strategic factors: production capacity, resource access, alliance strength, and logistics. Henderson asked von Schroeder what lessons he would draw from this analysis. The German thought carefully before responding. The obvious lesson that numerical superiority defeats quality was too simplistic. The deeper lesson involved the integration of equipment design with strategic realities. The Sherman wasn't good enough by accident. It was deliberately optimized for American strategic advantages. German tanks were optimized for tactical excellence, but ignored strategic limitations. Von Schroeder offered his own conclusion. We designed weapons for the war we wanted to fight. You designed weapons for the war you knew you would fight. We created masterpieces. We created tools. In the end, wars are won by tools, not masterpieces. Henderson asked whether this understanding changed von Schroeder's assessment of German military performance. The Panzer commander admitted it complicated his previous views. German tankers had fought courageously and skillfully with excellent equipment, but they'd been given an impossible task achieving tactical miracles to compensate for strategic failure. The Tiger and Panther symbolized this contradiction. Spectacular weapons that promised victory but delivered only delayed defeat. The American shared his own reflection on the Sherman. He'd started the war with contempt for the tank's limitations, knowing it was inferior to German armor in direct combat. He'd ended the war with profound respect for the Sherman's role in victory. It had carried him and millions of other Allied soldiers across Europe, functioning reliably under conditions that would have immobilized more complex vehicles. Its simplicity had been its genius. Von Schroeder asked the question that had been implicit throughout their conversations: would Germany have won with better tank designs? Henderson answered honestly no. German defeat was determined by factors far beyond tank design: resource limitations, strategic overextension, alliance dynamics, and the sheer industrial capacity of its enemies. Better tanks might have changed specific battles, delayed certain defeats, increased Allied casualties, but they couldn't have changed the war's fundamental arithmetic. The American concluded with an observation about military technology that transcended their specific discussion of tanks. Engineering excellence is worthless without strategic wisdom. Your tanks were engineering marvels deployed in service of strategic madness. Our tanks were engineering compromises deployed in service of strategic coherence. That's why the Sherman won the war. Von Schroeder sat silently for several minutes, processing not just Henderson's words but the cumulative weight of the week's conversations. His professional identity had been built on the superiority of German arms, the excellence of German training, the tactical brilliance of panzer operations. Understanding that this excellence had been strategically irrelevant was bitter medicine. Finally, von Schroeder spoke. I commanded the finest tank in the world. I destroyed 63 enemy tanks. I served with honor and skill. And none of it mattered because we were already defeated before we began. The Sherman won not because it was better, but because it was sufficiency. When multiplied by American production and logistics, became unstoppable. Henderson nodded, recognizing that von Schroeder had grasped the essential truth. The Sherman's victory wasn't about superior design, but about integrated system performance aligned with strategic reality. It was a lesson about modern warfare that transcended tank design wars, are won by nations, not weapons, by systems, not technologies, by strategic wisdom, not tactical excellence. As their final session concluded, Henderson asked von Schroeder what he would do with this knowledge. The German answered that he would record his experiences and analysis for future generations who might learn from Germany's mistakes. He would teach, if given opportunity, that military excellence without strategic prudence leads only to honorable defeat. He would remember that the finest weapon in the world is worthless if deployed in service of impossible objectives. Henderson stood and extended his hand. Von Schroeder took it, and the two professional soldiers, enemies by chance, educators by choice, parted with mutual respect. The Sherman had won the war not through superiority, but through sufficiency. Not through excellence, but through adequacy aligned with strategic reality. It was a lesson written in the burned-out hulks of Tigers and Panthers scattered across Europe, in the 49,000 Shermans that had carried the Allies to victory, in the mathematical inevitability of attrition warfare when one side possessed overwhelming systemic advantages. The captured German tank commander had learned why the Sherman won the war. It wasn't the answer he'd expected or wanted, but it was the truth. In modern industrial warfare, adequate weapons produced in vast quantities, maintained reliably, deployed efficiently. And integrated into coherent combined arms, doctrine will always defeat superior weapons that strain their nation's production, logistics, and strategic capabilities. The Sherman embodied this truth, and that's why it won.